What's up? What's up? What's up? It's your boy, the network, bro. I ain't got my phone today, so I ain't got no sound effects. But today's topic is section 3.31B, 4-byte AS number. This is a topic in the CCNP route exam. It's going to be known as the CCNP Enterprise Exam, exam code 300-101, version 2.0. Let's take a look at the exam blueprint, say where we came from and where we're headed. All right, folks, this is the exam blueprint, implementing Cisco IP routing. Again, this will be known as the CCNP Enterprise Exam. So this topic may or may not transition into that. However, when I was reviewing this was on the CCNP when it was called CCNP route. It may go into it. Most likely it will be. But anyways, we just wrapped up the section eBGP. Today we are going to be doing 4-byte AS number, and after that we'll review configuring and verifying private ASs. So what is a 4-byte AS number? First of all, let's talk about ASs. What's an AS? It stands for autonomous system. What's an autonomous system? An autonomous system could be your corporate network. It could be your service provider that has a group of routers sitting in an autonomous system, right? Let me give you a visual representation of that. So this could be like your corporate network, or it could be, again, your house if you have BGP, an AS assigned to you, right? So these networks are assigned an AS number. These two routers are sitting in AS 200. That one's sitting in AS 300, so on and so forth. That's in 100, right? Again, this could be your corporate network. This could be your business, or this could be your remote office, whatever the case may be. But you can be assigned an AS number, right? However, when they first came out with AS numbers, right, it was between any value between 0 through 65,535, right? Now, as you can see, they were split up into different ranges. The 0 is reserved, so you can't use that. 1 through 64,495 is assignable by IANA. That's the Internet Assigned Number. I don't remember what the last A is, but that's basically the company that assigns public IP addresses and autonomous systems numbers for public use, right? This range is used for documentation, reserved for documentation. This is for private use. That last number is reserved. So basically, we had 1 through 64,495 to work with. Now, you would think that's a lot of ASs, right? But nobody 10, 20 years ago, 30 years ago would have thought the internet would have grown to the size it has grown to today. Like, your phone can have an IP address. Your car can have an IP. There's so many devices that are out there. We did not realize how large the internet would have gotten, right? Same thing with the IP addressing scheme, right? We ran out of these numbers because the internet grew so fast. Same thing with AS numbers. We ran out of AS numbers. So a little history on that, right? Before January 2009, we had 2-byte AS numbers, right? So the range that I gave y'all right here, these were considered 2-byte AS numbers, right? We ran out of them so quickly, right? So we had to figure out a way to be able to have more AS numbers, right? Similar to running out of IPv4 addresses, right? So what the IANA did was increase the AS numbers by introducing 4-byte AS numbers in the range of 65,536 to basically 4.2 million, I believe it is, right there. That many AS numbers. Now, you would think maybe in a gazillion years we'll run out and be like, oh man, they didn't think the internet would grow this larger. But anyways, so we basically expanded our space of AS numbers. Now, there's 3 ways to write this down, or write these new AS numbers down, right? The old way is AS plain. We're going to break each one of these down, right? So AS plain is the old way, from 0 to 65,535. This represented as a regular decimal numbers. AS1 is 1. AS2 is AS2, so on and so forth, all the way you get to 65,535, right? That's the plain number way. It's just regular. Now, when they came out with the 4-byte numbers, they had to figure out a way for the to write the numbers larger than 65,535, right? So between 0 to 65,535, they're written as is, right? Without reading all of this right here, 0 to 65,535 is written as is, right? Anything larger than that, 65,536, it's split up in 2 numbers. 1.10 is 65,546. How, right? You look at this and wonder, how does this equal that number, right? Well, I'm going to show y'all a calculator that actually shows you how to do all of this. But I'm going to show you how to do it by hand first, so that way you can understand the math behind it. So you look at this number right here, 65,546, right? Basically, any number that's larger than this, you add a 1. You put a 1 there, right? And then you add, so this number equals 1, 65,535, right? So anything beyond that, it'll be 1.1. So 65,536 is 1.1. Actually, I'll take that back. 65,536 is just 1. 65,537 is 1.2. 65,538 is 1.3, so on and so forth. I'm going to show y'all a calculator explaining it again, right? So that is AS dot, right? These numbers are written as is. 65,536 and up is written in two numbers, right? The first number and then the second number. So one number dot the second number. And I'll show y'all again how to do that by hand. So AS dot plus breaks the whole range into two dots, or two numbers rather, right? So 6541 becomes 0.6541. Y'all get that right there? So this number, right, that's from the old range, right? 6541, it becomes 0.6541, right? 54,233 becomes 0.54233. Y'all still with me, right? We just added a 0 dot and then the number, right? Same thing with this. 544 becomes 0.544. For numbers above 65,535, we use the next high order bit value and start counting again at 0. So, like I was explaining before with AS dot, except that AS dot uses 0 through 535 and writes them as is. AS dot plus does this to all the numbers, split them up in two. So 65,536 becomes 1.0, right? 537 becomes 1.1. 538 becomes 1.2. What is 65,539? What do you think that becomes? Pause and think about it. We back. It's pretty simple, right? 65,539 becomes 1.2, right? So 65,538 is 1.1, 65,539 is 1.2, and so on and so forth, right? And that's AS dot plus notation. Now, AS dot plus, now remember, we have the 2-byte AS numbers, which are written with this right here, 0 through 65,535, the old way, right? Anything beyond that are 4-byte numbers, right? So we run into this issue where we have old routers that can only support 2-byte AS numbers and new routers that support both 4-byte and 2 bytes, right? So let's say you have a router that supports both the 4-byte ASs or AS numbers and the 2-byte AS numbers, right? That will be routers that have the newer iOS, right? And it's trying to speak to a BGP peer that only supports the 2-byte AS numbers, right? Well, we have a reserved number, which I don't know why it wasn't in that previous slide that I showed you. We have this reserved number that we're going to use, so that way it'll be backwards compatible with the new or the old. So that way the old iOS can speak to the new iOS and vice versa, right? So this reserved number is 23456, right? And I'm gonna show y'all this. I did not have this in GNS3, the iOS version that I could use this. So I had to bring out my old hardware to show y'all this, right? So when a new router talks to an old router, one that supports 2-byte AS numbers, it can use a reserved AS number, which is 23456, called the AS trans instead of its 4-byte AS number, right? Now we could use this command right here to show to change the notation, BGP AS notation dot, and I'm gonna show y'all an example of that. Here is a link to the AS plane to AS dot calculator. I didn't really want to show y'all this by hand, but if you want to, I'll show y'all. I mean, you could use this link to kind of go back and forth between the two. I don't think you really got to know how to do the conversion on the exam and stuff, but you do need to know the math behind it. Let's go ahead. Actually, I've already got some of these routers fired up. I got some hardware for y'all. So we got a Cisco 1921, a Cisco 2821 and an 1841 router. The I believe it's a 2821 is not fired up yet because that one is super loud and I didn't want to do that yet. But anyways, let me show y'all. I don't know if y'all can see. Let me unplug this real quick. So that is my routers right here, right? We've got, hopefully y'all can see this. So we got the 1941 here. We got an 1841 and a 2821. This is gonna be router 1, router 2, router 3. Hopefully y'all can see that, right? So from top to bottom, router 1, 2, and 3. And I'm gonna show y'all a little quick topology on GNS3 so that way y'all can see. Yes, I'm doing it the old school way, but the command that I was looking for, that BGP AS notation command, was not supported. So we're gonna make it work using hardware. Now this one right here, router 3, as y'all can hear, sounds like a damn airplane. Here goes to topology we gonna be working with right here. However, again, this is hardware. We got router 1, 2, and 3, right? Router 1 sits in AS autonomous system number 1. Router 2 sits in autonomous system 748351. However, when we do the math, it becomes 11.27455. I should bring up that calculator so y'all can see. Let's bring up that calculator. Okay, so here go that calculator, right? This is, again, I'm going to leave this link in the description below. If you got an AS, this is an AS plane number, we're going to transfer it or translate it to AS dot, right? So if we write numbers in the AS plane, right, again, let's say you got AS5, that becomes 0.5 for AS dot, right? Let's say you got 0. Obviously, that's going to be 0.0, right? But you can't even do that because why? 0 is reserved. We can't use it. Let's say we've got AS number 7,555. That becomes what? 0.75555, right? So we keep going all the way up, right? Let's say we went to 60,000. That becomes what? 0.60,000, right? We get to 65,000. That's 0.65,000, right? We keep going up, right? Everything is still written out plainly. We just adding a 0 in front of it, right? We get to 65, the last numbers, right? We get 65,534. That becomes what? 0.65534, right? And then we do .5 becomes what? 5, right? 6 becomes what? 65,536 becomes 1.0, right? It becomes 1.0. 537 becomes 1.1. 538 becomes 1.2. Let's say 65,545, that becomes 1.9, and so on and so forth. Again, let's go ahead and back into the routers. We got routers 1, 2, and 3, right? Router 1 has a loop back. Let's go ahead and look at what he's got. Show IP interface brief. He's got 10. He sits in the 10 network, right? And he's got a loop back quad 1. Router 2 has quad 2. It sits in 112.7455, right? Or that number. And he has that interface. Let's go ahead and go to router 2 and see what he's got. Now, I don't have a terminal server or access server, so I got to use my console cable to basically jump between these routers here. Enable. We're going to show IP interface brief. You see we've got 10.10.02 and 10.0.0.5, which sits in this network right here. And he is in quad 2 loopback, right? And then we have to configure BGP. I haven't configured BGP on any of these guys yet. Let's go into router 3 and see what he's got. Router 3 is the old clunky airplane one, sounding one. We got router 3, show IP interface brief. And we've got a couple of serial interfaces. Don't worry about these guys. Just worry about the gig interface that sits in the 10, that has a 10.0.0.6, which is up, and the loopback, which is quad 3, right? That guy right there. That's the clunker. So we're going to go into router 1 first and configure BGP. Here's what we're going to do. We're going to configure BGP between all routers using the physical interfaces and the ASNs listed. So AS1, AS748.351, and AS3. Then we're going to have to advertise all networks using network statements, and then we're going to view the BGP table using show IP BGP. So let's go ahead and back in the console router 1. If anybody wants to donate a terminal server to your boy, please do so, because I hate taking the cable and keep going back and forth between the routers. So we're going to go into global config mode and say router BGP. This is simple enough, right? One, we're writing that in AS plain. But before I do that, let me show you something. We do router BGP, and we can write this. This obviously can write using the using 4-byte numbers and the 2-byte numbers, right? And we could write it in AS plain, or we can write it in AS dot plus. We're gonna just do it in AS plain and say 1.0, 1, or just 1 rather. And we're going to give it a network statement of router a neighbor statement, and say his neighbor is 10.0.0 dot this guy right here, which he will be, or this guy right here, which will be 10.0.0.1. The remote AS, what do we say the remote AS is? From here to there, the remote AS is going to be 11.27455 or 748.351. You can pick your flavor. But let me show y'all real quick. We say remote AS. We'll say, let's say 748.351. And I think I already did that command though. Remote AS is cannot configure the local system as a neighbor. What did I just do wrong here? I'm consoling the router 1, right? Oh, my bad. So the neighbor's got to be 10.0.0.2. That's why. All right. So remote. So the neighbor. This is 10.0.0.1. Remote AS is 748.351. Right. Now, if we do a show show run, and look at the section BGP, you'll see it's written as is 748.351. But let's say we wanted to change that, right? Notation. We just do what we said here. To change the default display, we use BGP AS notation dot. This changes the 4-byte AS numbers from ASCII to dot notation. So we say BGP AS notation dot, right? And now if we run that same command, you'll see we changed it from 748.351 to that, right? Does that make sense? So now we've configured router 1. We don't have BGP up yet, but let's go ahead and advertise the network though. So we're going to say network 10.0.0.0 255.255.255.252. My bad. We got to put the mask. I always find myself doing this with BGP mask. So now do show IP BGP sum. We're not up yet. We're not going to be up yet. Do show IP BGP sum. We're not up yet, right? So we're idle. Remember those states, right? BGP has not been established yet. So let's go into router 2. We're going to do the same thing. Configure BGP. Hopefully we've got neighbors. Configure. Now, again, the clunky one, the airplane one, the one that's basically the dinosaur, does not support the 4-byte numbers. And I'm going to show y'all how we make this work. So we're going to say configure. We're going to go, we're in router 2 now, right? Configure terminal. We're going to say router BGP. Now, this is one of the newer ones. This is an 1841 router. He can support both notation, right? So AS plain or AS dot plus. We're going to say router, he's in BGP 748.351, right? Let's write it in this just in case, or just because, right? We're going to say, remember, when we put it in here, we wrote down 748.351 is what we did. But let's write down 11.27455, right? 11.27455. And we're going to say his neighbor is 10.0.0.1, and the remote AS, so his neighbor, the remote AS, is sitting in remote AS1. And hopefully BGP comes up. Well, that's coming, and it came up real quickly too. There it is. So now we're going to advertise our network 10.0.0.0 255.255, even though it's directly connected, 252. Don't forget the mask statement. Do show IP BGP sum. And let's see what we're working with. It's been up for 28 seconds. That's a good sign. Let's see what are we showing with our. Notice it says even though we said router BGP this, it says our local AS number is 748351, and BGP came up. Isn't that great? That's the difference between the 4-byte numbers and the 4-byte numbers and the 2-byte numbers. However, this is just the notation that's written differently. Let's go ahead and go into router 3, which is the clunky one. Now this is the curveball, right? How are we going to make this work? So now we're going into router 3. This is the old guy, right? This is the old guy right here. We're going to go into, we've already looked at his interfaces, right? Show IP interface brief. He has an interface that sits in the 10 network right there, and he has this loopback. We're not going to worry about the loopback, but it's loopback 3, right? That's this guy. This is the clunker, right? That's the fat router. This is the 2821. I got that on offer up for like $5. So there's no excuse for not having hardware. Configure terminal. We're going to say router BGP, but check this out. He only supports the AS plane numbers written in 1 through 65535. That's back when they didn't think we'd have that many AS numbers, more than that, right? So again, around 2011, that's when we started running out of AS numbers. They've been pretty much exhausted, and they came up with more AS numbers up to like 4.2 billion or something, like 4.2 million. I don't know what that number is. But anyways, this one only supports 65,535. So how are we going to make this work? How are we going to make him our neighbor, right? If we do 748351, it's not going to accept it, right? What if we do the other number? This one right here. If we make him a neighbor using that? We're going to say 11.27455. That does not work. Remember what I said about backwards compatibility? We said that when a new router talks to an old router, one that supports 2-byte AS numbers, it can use a reserved AS number, 23456, called AS trans, instead of its 4-byte AS number. And that's what we're going to do. We're going to use this number to communicate with our BGP peer. Router BGP 3, and then we want to make him our neighbor. How do we make him our neighbor again? We're going to say neighbor BGP. The neighbor is 10.0.0. This guy right here, which is 10.0.0.5, and then the remote AS is not. We said it was 748351, but again, it don't understand those numbers. So we got to use that transit number, 23456. That's the remote AS, and we shall see. Hopefully BGP comes up. While that's coming up, let's work on our network statements. 10.0.0.4 mask 255.255.255.252. We probably need to make router 2. We probably need to go back into router 2 and work on something here. Do show IP BGP sum. It's active. Looks like it's working on it. Oh, we need to do the same thing on router 2. We need to put router 3 as our neighbor. So let's go back into router 2. Router BGP. We said 11.27455. We said our neighbor is router 3, which is 10.0.0.56 mask remote AS. We know it's 3, right? But let's write it in AS in another AS number. Let's just say 0.3. Oh nope, that's not gonna work. Thought remote AS3 was that, but we can't do that. So let's just say 3. What am I thinking? And there it is. BGP is now up. So now these two are neighbors, right? Router 2, router 3. So let's go back into the clunky one, router 3. We're going to go on router 3, this guy, and take a look at what he sees now. Show IP BGP sum. Do show IP BGP sum. And neighbor's been up for 24 seconds. And notice the local AS is 3. And he says that router, this guy, is in AS23456, when we know, in fact, he's actually in 748351. What else are we going to do? We're going to look at, let's see if we can ping. Router 3 can ping router 1, because I think they are seeing each other's routes. Let's do a show IP routes. And can he see that network? Yes, he sees the 10.0 network. He sees this network right here. He sees this network right here. BGP is 20. So let's see if we can ping router 1. So ping 10.0.0.1. And we got a reply. What else we want to see? Let's do a show IP BGP. And you can see the next hop to get to the 10.0 network is 10.0.0.5, which is right here. And notice it says the path is 23456, even though really the path is this AS number, which is 748351, or that. But this clunky one does not understand that, so he just sees 23456. Let's look at it from the vantage point of router 1 and call this a day. So from router 1, let's see his routing path. Let's show IP BGP to get to router 3, which is the 10.04 network, 10.0.0.4 network. He says take the next hop of 10.0.0.2. The path is 1.1. He sees it because he supports 4-byte numbers and AS plain, or AS dot rather. He says the path is to take 1.1.2.7.4.5.5, and then the next hop is AS3, which is right there. What else can we see? Show IP, and he can ping him too, right? Ping 10.0.0.6. That's how you get there. And you got to reply immediately. That's all I got for y'all today. That's my YouTube page. That is my Twitter handle. If you like this video, please comment, like, subscribe to the network, bro.